Welcome, friends. Let us continue our product analytics section. So, I have brought another very important tool that is useful in product analytics, and that tool is called A/B testing. So, A/B testing is used in many way in product analytics, in marketing analytics, and in many business applications. So let us start with we have already covered the hypothesis testing. So it is so the A/B testing is nothing but the two sample test. So here we have the two samples. It may be the your customer data before launching the new ad campaign, or and after the customer data after launching the ad campaign, and then you want to compare whether your ad is effective or not. Similarly, suppose you have launched a marketing campaign and you want to measure what impact your marketing campaign did on your customer. So if you want to know, suppose for example you have defined a metric like engagement rate or something other, then you can use that metric to know the effectiveness of your marketing campaign. So for example, suppose uh, you have the data before launching the marketing campaign and you have the data after the launching the marketing campaign. So you can compare both the data, whether both are statistically uh, significant, statistically different or not. You can determine using this tool, which is called A/B testing. So we have already covered the basics of hypothesis testing in our previous section, in our two sample t test or z test. So we performed these things. So this is not new. Only thing is that we are now going to apply it in a in a case business case example. So here let us discuss the importance of A/B testing in product analytics. So A/B testing holds significant importance in product analytics due to several key reasons. So first is data driven decision making. So how you will measure the impact of your marketing campaign or the ad campaign? So you need some tangible, you need to show some tangible benefit, and that benefit you can only calculate if you are able to do the A/B testing. So suppose A/B testing allows product teams to make decision based on empirical evidence rather than assumptions or intuition. So it gives you an empirical evidence instead of assumptions or institutions. So by comparing the performance of different versions, A, B, A and B of a product or feature, teams can objectively assess which variant leads to better outcomes. So, what outcomes depend upon your business objective, could be conversion rate or engagement or revenue, or you have to define a metric. So, for example, ad campaign, how much an ad lifted your sales. If you want to determine this, then you have the sales data before launching the ad, and you have the sales data after launching the ad. You compare whether both the sales data have are statistically same or different. So you conduct the hypothesis test and determine whether your sales has been lifted or not with your ad campaign. So suppose you have invested money in ad, so you can do the cost benefit analysis in that situation. For example, uh, the money you have invested, and you you now know the sales lift because of the ad. So you can compare, you can do the cost benefit analysis in that case. Similarly, you can measure the engagement of your customer. Uh, you can quantify the benefit in that case. Now coming to the optimizing user experience. So A/B testing optimize your user experience. For example, it helps optimize the it helps you to identify design, which design, layout, or content are means are functionally resonating your user. So which layout resonates your users well, you can determine. So by testing variations of elements such as call to action button or so you can create multiple variant of your product by changing few design or few elements of your product, and then you can test on your customer. Your study group, you collect data and do A/B testing and see whether the change of design has any impact on your customer or not. So you can test various variants of your product, so it enables you to select the best variant that maximize user satisfaction or retention rate. Similarly, it mitigate risk. So it mitigate your business risk. Suppose you are planning to launch a new product or new version of product or new version of website. So in that case, you want to mitigate the risk. You do not know what impact of your new product, new version of your product will be having on your customer. So there is a risk of failure. So in order to avoid the risk of failure, what you do, you select a study area, a subset of your customer base, and then you launch your new product or new version of your product on those subset users. So and you conduct the A/B testing in that situation. So suppose so in that case, suppose if you find any difference between before launching your new version of product and after launching of your new version of product, you can determine what impact your new version of product is causing on your customer. First you need to know whether is is there any statistical difference, statistically difference between the performance of your older version and new version. So for that you need to do the A/B testing. So you conduct A/B testing. So this reduces your business risk. So since you are launching your new version of product uh, in a small subset of users and determining whether your new version of your product is statistically different or not, and what benefit it is bringing to in your it brings in your business. So in this way you can mitigate the risk. So if your product is causing any positive impact on your customer, in that only in that situation you will launch your new version of product world means to your entire users. So this in this way it mitigate the risk of failure. So now iterative improvement. So you continue doing A/B testing and fosters a culture of continuous improvement within the product team. So by iterative experiment, by creating more variants of your product, you can do increment. You can bring the increment changes and increment positive changes to your product. So you can improve the performance of your product iteratively. So uh, this so A/B test is a tool that enables you to do such iterative improvement in your product. Similarly, help it is helpful in maximizing the return on investment. So A/B testing helps maximize return on investment by identifying and prioritizing high impact optimization, by focusing resources on initiatives that have demonstrated positive outcomes through testing. So you what you do, you organize your resources, you allocate your budget more on high impact means project. So suppose you want to improve a part of your project, uh, suppose you want to improve a project page, suppose website page. So requires more, means you conduct the A/B testing for new version of your page design. Then in that case, suppose it gives you a positive feedback by A/B testing, so you can allocate more resources on developing such product, so such web page. So this is how you can optimize your allocation of resources. So you can prioritize high impact uh, uh, projects. So in this way you can maximize your return on investment. Similarly, it gives you a personalization and segmentation. So A/B testing enables personalization and segmentation strategies by tailoring experiences to different user segments. So based on their preferences, behaviors, demographic. So by testing variations targeted at specific audience segment, product team can deliver more relevant and more engaging experiences. So you can design a more customizable product for your customer. So for example, you have a different segments of customer, so you can design a product in such a way that it is more customizable. So you choose those features which are which resonates more to that particular group. So by conducting the A/B testing, you can do this also. So overall, A/B testing serves as the cornerstone of a product analytics, providing actionable insight that drive continuous improvement, mitigate risk, and ultimately enhance the overall value proposition of products and services. So we have seen the impact of six applications of A/B testing in marketing. So uh, it depends how you use A/B testing, but A/B testing is a very powerful tool that gives you a lot of insight. So let us start with a case study of e-commerce product page redesign. So as we were discussing that we can design a variant of product, and we can test on a small group of our customer to know is there any statistical difference between the older version or the new version uh, has. So you can determine this. So let us discuss a case study on e-commerce product page redesign. So here our our success criteria or the our metric is conversion rate. So uh, we will do the A/B testing to know is there any impact on the conversion rate of new version of page or not on the customer. So an e-commerce company team, e-commerce company product team has redesigned a page. So they want to test whether the new page or new version of the page has any impact on the conversion rate or not. So the UX designer has put in significant effort in redesigning the product page, aiming to improve the conversion rate. The product manager informed you that the current conversion rate averages around 13% throughout the year. The team would consider 2% increase in the conversion rate a success, which means achieving a conversion rate of 15% with the new design. So this is what their objective is. So the objective of this project is to assess whether the new product page design leads to a statistically significant increase in the conversion rate compared to the current design. So first, so they want to determine whether the new product page is statistically has significantly improved the conversion rate or not. So let us form the hypothesis. So we will test the following hypothesis. So null hypothesis in this case is the new product page design does not lead to a higher conversion rate, and the alternate hypothesis is that the new product page design leads to a higher conversion rate. So methodology is data collection. So gather data on user interaction and conversion for both the current and the new product page design. So you need to have data set that contains the conversion for both the older page and the newer page. And second thing, after collecting the data, you need to perform the hypothesis test or two sample hypothesis test. So, or in other words, it is also called A/B test. So we will perform the A/B test to know whether any statistical difference is there or not between the older version and the newer version of the page. So by evaluating the impact of the new product page design on the conversion rate, we aim to provide valuable insight for decision making within the product team. So this analysis will inform you whether the design changes have successfully achieved the desired increase in conversion rate or not. So first thing, whether is there any conversion rate difference or not. So how we will, so let us form the hypothesis. Since it is the case of proportion, because in conversion rate we have a total data out of which some of the data will be having a conversion rate or some will be having no conversion rate. So we, this is the case of proportion, not the mean. So we talked about the case of proportion. So here our null hypothesis is that the two proportion is similar, is same. So P represent the conversion rate of proportion. You can say uh, uh, proportion or the rate. So it's a case of binomial distribution. So we know how to convert binomial distribution into normal distribution. We have already discussed and this in our hypothesis test and statistical inference section, how to convert binomial distribution into normal distribution. How we can determine the mean, we can determine the standard deviation if we know the proportion. So this is the case of proportion, because either either the conversion rate will have either uh, it is converted or it is not converted. So you have either 1 or 0. So only two case you have. So you will determine the proportion in which the total data set, how many data set is having a successful conversion rate, a successful conversion. So here you know the proportion. This is the case of a proportion. So this is the hypothesis. The null hypothesis is that both proportion is belongs to the same population. So our null hypothesis is that both proportion belong to the same population. So in other word, there is no difference between your older page and the newer page in terms of conversion rate, or your new page design is unsuccessful because it is it is not having any impact on the conversion rate. And what is the alternate hypothesis? That the two proportion is not similar. So in this case, we will perform two-tailed t-test to know whether is there any statistical difference between the two proportion or not. So we first need to define the confidence interval. So in this case, the confidence interval is 95% or significance level is 0.05. So we have already discussed what confidence interval is and what significance level is in our statistical inference part. So no need to discuss it here. We know the proportion that we want. What we want first, we want to determine whether the two proportion is same or not, statistically same or not. If we know if they are alternate, if we reject the null hypothesis and if we prove that the two proportion is not same, then we will explore whether the new version of the page has a positive impact on the conversion rate or not. And if we are not able to reject the null hypothesis, so in that case, the new page design has no impact on conversion rate. So it will not achieve the business objective of uh, uh, improving the conversion rate. So business objective was what? To improve to the conversion rate to 15%. Earlier, the current conversion rate was 13%. And since it is not statistically, so let us test the hypothesis. So we have formed the hypothesis. Our null hypothesis is that the two proportion is same. Alternate hypothesis is that two proportion is not same. We have defined the confidence interval of 95%. It depends upon you. If you want to have less margin of error, then you reduce this confidence interval to some lower value. And if you want to have more margin of error, then you can you can increase the confidence level. Accordingly, 1 minus confidence interval will give you the significance level. So here significance level is 0.05. We will calculate the p value. So if p value is more than the significance level, in that case, we cannot reject the null hypothesis. In that case, our conclusion would be with 95% confidence level or with X% confidence level, whatever confidence level you have chosen, we cannot reject the null hypothesis. So p value is the key here, or we can do the Z test. So if Z value is more than, if Z value falls within the range of confidence interval, then we can 95% confidence interval, then we can say that we cannot reject the null hypothesis. So let us start the test. So we require the basic package like NumPy, Pandas, SciPy, and stats model. So we require stats model also. And in stats model, since we want to do the Z test, so we need in stats dot proportion, we require these two functions. So one is the proportion Z test. It will perform the proportion Z test because our case is of proportion. It is not the case of mean. So we require proportion Z test and we require proportion confidence interval. So in this case, we are conducting on a data set for which a proportion is given instead of mean. So we will perform the proportion Z test and proportion Z test. So let us load the data. You can download the data. It is there on Kaggle, or I will also provide you the data. It is open source data. So here we have the timestamp, here the user ID, here the landing page. So this page we are interested. This is the old page, this is the new page. So whether new page has any impact on the conversion rate or not, we want to know. And this converted column shows the conversion. Means 0 means no conversion, 1 means conversion happened. So a proportion is given. So we want to do the proportion uh, Z test. So let us start. So let us see whether is there any null value present in the data set or not. If present, then remove it. In our case, I don't think any null value is there because you can see 0 0 value. So there is no null value present in the data set. Now let us talk about the unique value that let us talk about the versions. So we have the old page version and we have the new page version. And we want that these pages has whether these pages whether the new page has any impact on the conversion rate or not. So let us divide the data into two part, one for old page and one for new page. So we have two data set, two data frame. One is containing the old page data set and another is containing the new page data set. Now we will calculate the rate, means what rate the conversion is happening. So let this you can calculate by applying the mean value. So mean value give you the proportion. So it will give you out of the total value, how many value has been converted. So this you are calculating the proportion. So now you have the this proportion. So let us perform the hypothesis test. So you have to give the total value. So here you have to give the total value. So total value you can calculate the conversion rate into the total number of data. So or you can also do the sum also. So in that sum will also give you the same result. So here you can calculate. So this is the mean value and you multiply is with total number of value, you will get the you will get the proportion. So and also provide the number of value in both the uh, samples. So after running this code, you will get the p value and the z score. So here the z score is 1.37 and the p value you are getting is 0.171. So now you can calculate the upper and lower bound of the confidence interval of both the old page and the new page. So here you can get the upper and lower bound of the page. Now, if p value, since you are getting the p value 0.171, which is higher than 0.05, that is the significance level for 95% confidence interval. So since the p value is more than that, we cannot reject the null hypothesis. So our result is that stat our result is not statistically significant. There is no evidence that we can reject the null hypothesis. So there is no difference between A and B version of the product. There is no difference between the new page and the old page. It means that the new page is not improving the conversion rate. So the new page design will not achieve the business objective of the project. So we will say that the new page is not going to improve anything because it is not statistically different from A. So let us do some plotting. So for plotting purpose, we can plot the standard normal curve and place the z value there because we are calculating the z value. So you can see, so by first you need to convert the pooled standard error, you convert. Once you get the standard, we already covered this what standard error is in our statistical inference part. So we have already discussed. Now you can, with the help of standard error, you can calculate the upper and lower bound of the confidence interval. If you know the confidence interval, then we can move further. So now we can we can plot the standard normal curve. So we already talked about what standard normal distribution is. So its value is between 0 and 1, where and the mean value of the standard sorry, its mean value is 0 and its standard value is 1. So we have already discussed the standard normal distribution. So a standard normal distribution has 0 as a mean and 1 as a standard deviation. And you can see that the Z score is falling between the confidence interval. So that is the reason why the two group is not not different. It is same. That means the new page uh, uh, and the new page is causing no improvement on the conversion rate. So let us plot the old and the new distribution, conversion rate distribution. So you can see, so this is not giving, but this is this saying that there is no significant difference between the older page version and the newer page version. So what we can conclude, the Z score of the A/B test is 1.37 with a corresponding p value of 0.17. Based on these results, with 95% confidence can't reject the null hypothesis and conclude that there is no evidence of statistically significant difference in conversion rates between the between the new and the between the old page and the new page. So what we are testing, we are testing the impact of old page and the new page, and there is no statistical evidence that we can say that the two page uh, has different impact on conversion rate. So we cannot say that, and it means that our new page design is not achieving our business objective. Our business objective is to improve the conversion rate to 15%, and our new page cannot help me us to achieve our business objective. So this is what the case study is. So let us end this hypothesis test part. In the next session, we will be exploring some more advanced topic on analytics, on marketing analytics. So thank you very much for joining this session. Stay tuned in my marketing analytics course. Have a nice day. Thank you very much.